So we're going to look at the sine and the cosine law. The sine law tends to be a bit easier to use. Okay, I'm just going to write them off to the side here. The sine law looks like this. Basically, the sine of angle A divided by length of side A is going to be equal to the sine of angle B divided by the length of side B, and sine of angle C divided by length of side C. Okay, so those are in proportion to each other. The cosine law looks like this. It's basically Pythagoras theorem. So a squared is equal to b squared plus c squared. And then because it's not 90 degrees, we have to adjust for it with 2bc cosine of the angle that is on the opposite side here, so angle A. Okay, maybe I should do this the same as I did the top one here. So side A, we'll use capital letters. So A squared is equal to B squared plus C squared minus 2BC BC cosine of angle A. Okay, so those are the formulas. Here we've been given two sides and an angle, so this indicates we probably should use the sine law, but let's just check. So we have the angle here, side, side. So the angle, as long as we have, the way that the sine law works, as long as we have an angle and an opposite side pairing, this is going to work. Okay, so sine law will work for an angle and opposite side pairing. So when I draw my triangle in here, it looks kind of like this. Now we can solve this, but because it is angle side side, we have to be aware that this is an ambiguous case situation. So I'm going to solve the first triangle first, and then we'll solve the second one. Okay, so I'm going to do the first problem in blue here. So I'm going to use the sine law. I want to find out angle B here. So this is angle B. So I'm going to say that sine B over 40 is equal to sine of the known angle 52 over 34. Okay, and then solving for sine B, so I get sine B is equal to 40 times sine of 52 degrees divided by 34, and that gives me a decimal value. Okay, 40 divided by 34 times sine of 52 degrees. It gives me 0.927. Okay, so then I'm going to solve for the angle B by using the arc sine of 0.927. Okay, and because it's a triangle, I don't need to worry about theta 1 or anything like that. It's an alternate angle. So I'm getting 67.98 degrees. Okay, so that angle in here is equal to 67, about almost 68 degrees. Okay, so once I have those two, I can figure out the third angle there. So I can add those two angles add up to 119, almost 120 degrees. So 180 minus that is going to give me an angle up here of 60.02 degrees. Okay, and again I can use the sine law one more time to solve for side C. So side C, I'm going to write side C over sine C. I can use the reciprocal form of that sine law. So 60.02 degrees is equal to, and I'm just going to use the 34 and 52 degree angle. Okay, so then solving for side C, I get sine of 60, whatever that is, times 34 divided by sine of 52, and that gives me a length of 37.37. In fact, I'm just going to round the side lengths to 4, and we'll call that centimeters for now. Okay, so there's our side length. Okay, so that side C is 37.4. We have our angle 67.98, 60.02, and that solved that particular triangle. So that's perfect. Except there is another triangle that's actually possible here, because I can still have 52 degrees, 40 degrees, and my length of 34 degrees can be oriented in this way. Well, I don't have any other angle to solve for here. When I solve for sine B, I end up with 67.98. Now, I kind of lied when I said that there's no theta 2. There is a theta 2 here, right? Because this angle in here is the one we want. We have an angle here is 67.98 degrees. And there is that red angle there must be the supplementary angle to it, or in fact theta 2. Okay, and I'm going to call that one theta 2. So angle B part 2 is going to be 180 degrees minus 67, the original theta 1 angle, so 67.98 degrees. Okay, so that other angle, which gives me a different triangle, is going to be 118.02 degrees. Okay, so this is what that angle is, 118.02 degrees. That's going to make the top angle here a little bit different, because that triangle has to add up to 180 degrees. So I'm going to go 118.02 plus the 52 degrees, and I'm going to subtract that from 180. Okay, so I get 9.98 degrees up here, 9.98 degrees. Okay, so just going to double check my work here. Okay, so this is actually 112, isn't it? Sorry, my math is off. 112.02. Okay, so this is going to be 112.02. So that makes this angle plus 52, then minus 180. That's going to give me 15.98 degrees up here. Okay, so there's the angles of that smaller triangle. I still need to solve for that third side. Okay, so I'm just going to make sure I've highlighted all my parts here. So angle B, what's that one? Okay, angle C, where did I get angle C? Angle C is this one here. So angle C, I didn't actually list it out, is 60.02 degrees. Okay, so for B1, that's going to be B2, that's going to be 112. So this will be C2, angle C, I'll call it C2, is equal to 15.98 degrees. Okay, so there's my C2. Okay, and let's clean that up a little bit to make that look like an angle. And then solving for side C, so C over sine of 15.98 degrees is equal to, I'm going to again use 34 and 52 degrees. Okay, so sine 15.98 times 34 divided by sine 52. Okay, that's going to give me a side C length of 11.88. We'll just call that centimeters. Okay, so there it is. I've solved the triangle. So I've got all three angles, all three sides of both triangles. Okay, now depending on which one you use, the blue or the red, you get two different solutions. So this is what we call the ambiguous case, and we always have to check for that whenever we have this angle side situation. Okay, we always have to check for that ambiguous case. Now, I'll show you later that there are some exceptions to this ambiguous case that we don't have to worry about.